Hello Year 12. This is a guide for writing a report for the ions investigation. What we'll look at is finding the ions present in a solution, an unknown solution. And we will find the cation and we'll find the anion, and therefore we'll be able to find the compound itself that's dissolved. So let's make a start. What you'll need for this is the ion flowchart that we've been using in class. So the first step for the cation test is to add a few drops of sodium hydroxide. Now in this case we observed a white precipitate and we concluded that it's either one of these ions. The reason for that is that only these ions form white insoluble hydroxide compounds, in other words precipitates. The next step is to add excess sodium hydroxide, and we observe that the precipitate disappears. That enables us to narrow it down because only these three ions form a soluble, colourless, complex ion compound with excess of hydroxide. Next step is to wash the test tube out and to put a new sample in it. And the flowchart instructs us to put a few drops of ammonia solution into the sample. Again, we see a white precipitate. So that's not surprising because we did get one with sodium hydroxide, and we know that ammonia contains sodium hydroxide, so we're not learning anything at this step. So ammonia contains hydroxide, and it'll be one of those hydroxides again. With excess ammonia though, we can learn something. In this case, the precipitate remains, so there's no change. It stays murky, in other words. And so that means it must be either aluminium or lead. If it was zinc, it would have disappeared because zinc is the only one that forms a complex ion compound of those ions with ammonia. But none was seen, so it must be either one of these two that doesn't form an ammonia complex ion. Next step is to wash the test tube out, put a new sample in again, and add sulfuric acid. The reason for that is sulfuric acid contains sulfate, and we're interested to see whether we'll get the lead precipitate. In actual fact, we didn't. There was no change, so we can conclude that it must be aluminium because aluminium sulfate is soluble in water. And you could also say that lead sulfate is not, and it wasn't seen. Okay, so we concluded now that the cation is aluminium 3+, and now we can go up and write our equations and name our precipitates. Now we if we know the cation is aluminium and we added sodium hydroxide to it in the first step, then we can conclude now that that must have been aluminium hydroxide that we saw, and the appropriate equation is this one. Now don't forget to balance it. Remember, the aluminium hydroxide formula has 3 hydroxides in it, therefore we'll need to put a 3 in front on the left hand side. Now it disappeared with excess, so there's no precipitates as such, but we did form a complex ion that's soluble, as indicated by the AQ on the right hand side. Again, remember to balance those equations. Okay, any other precipitates? Oh yes, this step here, the fourth line, we saw a precipitate, and as we said before, it will be the same as the other one up there, the top, because ammonia contains hydroxide, and we just write the whole thing out again. With excess, there was no change, so there's nothing, no equations to put in here. Everything's finished as far as that goes. Okay, so that's the cation sorted. We've worked out what it is and we've justified all our steps. Let's go to the next step then, and that's testing for the anion, the negative ion. We flip over our chart. First step is to test it with litmus paper, red litmus. We're checking to see whether it turns blue. In actual fact, it remained red, so that means that it's not hydroxide ions. Doesn't contain hydroxide or carbonate ions. Otherwise, the solution would be alkaline, and it's not. Okay. So next step is to add barium nitrate solution to a sample. In this case, there was no change. The solution is just mixed with no precipitation. So we can conclude that it's not sulfate. Now the reason we can say that is that all anions except sulfate would form a soluble compound with barium, or we've added barium to them, and so sulfate would not. You would see a precipitate. You could add that if you wanted to. Okay. Now we clean the test tube, put a new sample in it, and add silver nitrate to it. In this case we see a white precipitate, so we can conclude that it's either chloride or iodide, because silver iodide and silver chloride are both insoluble in water. Next step is to add ammonia solution, and we see the precipitate disappearing if we add enough of it and give it a good shake. So we can conclude that it must be chloride. Okay, because silver chloride forms a soluble complex ion compound with excess ammonia. Now we can go and name any precipitates. So the first step, there was no precipitate. Second step, no precipitate. Fourth line, we see there is a precipitate, so we're going to name that now. Since we know it's chloride, it must be silver, the cation from what we added, and the anion is for the unknown that we found out. Silver chloride, and then we write our precipitation equation that goes with that. Now that disappeared with excess ammonia, so we must have formed a complex ion, and indeed we did. There's the complex ion with silver, so you'd have to know how to do that formula. It will be given to you, a list of complex ions. So there's 2 ammonia molecules in it, so we have to do the balancing, of course, like before, putting 2 ammonias this time to finish it. And now, since we know that the cation is aluminium and the anion is chloride, then the compound must be aluminium chloride.